What's up? So in this video we're going to talk about how to derive sum and difference formula, which is cosine alpha minus beta, cosine alpha cosine beta minus plus sine alpha and sine beta. And let's start with what does this formula mean? That means actually you have two angles, alpha and beta. You take the difference of these two angles, and that's equal to cosine alpha cosine beta plus sine alpha sine beta, which actually give us some advantage in our real problems. Like, let's see, from the most basic trick, we know sine 45 degrees equal to root 2 over 2, and sine 30 degrees equal to 3 over 1/2. Now we want to know what is sine 15 degrees. You might look, oh my gosh, what is 15? I don't have that on my unit circle, but you can actually express this as 45 degrees minus 30 degrees. And that's where our difference formula come into like real use. So let's start actually how to derive this formula. So let's first look at what is this formula. This formula is like write cosine alpha minus beta in terms of cosine alpha, cosine beta, sine alpha, sine beta. But how are we going to find the relationship and to prove this or derive this? So the best way is just draw something on the unit circle and look and see what happens. So let's see. Assume this is a unit circle, and I make a angle, and let's call this point P, and let's call this angle beta. How's that? So the coordinate for P is just cosine beta, sine beta. Very easy, right? And let's make another angle. Why don't we call this angle alpha? And let's see. Let's call this point Q. And cosine alpha, sine alpha. Alright, so this is good because we already have cosine alpha, cosine beta, sine alpha, cosine beta, sine beta, which we need to express in this equation or formula. Now, let's see, what are we going to do from here? We want to try to find something that looks like alpha minus beta. And you see, oh, alpha minus beta, that's just this little angle. Alright, let's call this point O, okay? Just angle QOP. Oh, that's really easy. See, this angle is just alpha minus beta. So, that's good. We got alpha minus beta, we got beta, we got alpha. And we got sort of like a relationship, right? So let's see, what can we do here? Alright, now, why don't we actually connect Q and P and form a triangle? Let's just see what happens. Alright. So Q and P connected, so that formed a triangle. QOP, which OP and OQ are the radius, and QP is just the line that we just connected. So now, what are we going to do from there? Hey, actually I want to try to turn this triangle so that OP actually lies on the x-axis. So that way, P's coordinate will be 1 and 0. Wouldn't that be like so much easier? So let's try this. I better draw another circle. Alright, let's draw this as a blue circle. It's too bad. Yeah, that's better. Alright, so as I move QOP all the way over there, just turn this triangle with the point O. So it's OP and OQ should turn somewhere here, right? Q. And we still connect this. Do you agree this? Let's call this Q prime, the P prime past that. So that way we won't get confused. So do you agree with QOP? This triangle is actually congruent to triangle Q prime OP prime. How do we prove that? Side angle side. We know this angle. This angle is alpha minus beta, right? Because you just turn this angle will never change. And OP is the radius, OP prime is the radius, OPQ prime is also the radius, which by side angle side, it's an easy geometry. We know those triangle QOP is actually congruent to triangle Q prime, O prime, P prime, I guess. So now what do we do from here? Why don't we find the coordinate of this Q prime? This actually should be, let me use the green one. Cosine alpha minus beta. Oh my gosh, alpha minus beta. Sine minus and 1, 0. So now we have a expression that contains cosine alpha minus beta and cosine beta, sine beta, cosine alpha, sine alpha. Now what we need, just piece those little puzzles together to form this huge formula. How do we do that? So we know those two triangles are congruent, and by CP/CTC we also know Q prime P prime is equal to QP. So that means this line segment, is equal to this segment. And this is not hard to see. You just turn this. This is the triangle is congruent. This line segment will always be congruent. Now, since this is congruent, why don't we find the distance of Q prime P prime and QP? See what QP really is. So QP by distance formula is just cosine alpha minus cosine beta square plus sine alpha minus sine beta square. And this is going to take a ton, maybe not a ton, just like a few minutes of algebra to do this. Since my whiteboard is so small, I'll just write the result for you. If you don't trust me, you can do it by yourself. Just pause the video. This is equal to, let's see, 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. And for Q prime P prime, this equal to cosine alpha minus beta minus 1 squared and plus sine alpha minus beta minus 0 squared. And same, just trust me for this one. Alright, so this should be cosine squared alpha minus beta plus sine squared alpha minus beta. And now we have some sort of expression for OP and OP prime. Since they are equal, why don't we just put put those two expressions on two sides of the equation and see what happens. And that's what we're going to do now. And allow me just to erase those big circles so we can actually have some room. So keep in mind, OP prime is always equal to OP, right? So just memorize that. Alright, since those two equations are the same, we can just put them into the equation thing. From this step, you can already see we can take off the square root sign, and we can also see cosine something plus sine square something that's equal to 1. That's our trig identity, or Pythagorean identity. So this is really equal to this. So we can reduce the equation by taking out of the square root sign and apply our trig identity. Now we just do a little bit simple algebra. 1 plus 1 equal 2. And 2, we can cancel out 2. Keep in mind, well, what do we want for this proof? We want cosine alpha minus beta in terms of sine alpha, sine beta, cosine alpha, cosine beta. Now we just gotta isolate this term. So divided by -2 on both sides. Cosine alpha minus beta to cosine alpha cosine beta plus sine sine beta. And oh yay, congratulations. This is our difference formula. It's not a hard proof. It's just like you have to think through it. The most important step is you have to know O prime P prime is equal to OP just by those congruent triangles. And afterwards you just do a bunch of algebra and then you're done. So now you derive the difference formula, which is good. Alright, let's mark those two. So let's see, we actually got it. And yay! But I'm gonna tell you something. There are 6 of the formulas, and the other 5 we don't have to use a ton of proof. We can just prove it easily by cosine x equal to sine power 2 minus x, which can easily leads us to another useful formula like sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And yep, okay, thank you for watching, and if you have any question, just comment below, and it's good.